For our research paper topic, we decided to do automotive pass-by noise techniques and standards. This presentation goes into detail about automotive pass-by noise techniques and standards. We discuss what pass-by noise is, how it's tested, and the laws and regulations surrounding it. Automotive pass-by noise is the noise heard from a vehicle as it passes by. Pass-by noise is an important contributor to the appeal of automotives. A well-engineered pass-by noise can make the vehicle's performance seem elite, and a poor pass-by noise can be very unappealing. In high traffic areas, the noise from all the vehicles accumulates and can have negative impacts on our environment. Exposure to excessive noise for a long duration can lead to mental or physical health problems. For this reason, pass-by noise limits are established for each vehicle to assure that the noise levels remain low. There are many tests to regulate the pass-by noise levels of vehicles, but the most common is ISO 3623 from 2016. This testing method has established standards around the world. Many case studies have been conducted to determine the pass-by noise levels experienced by the population and how the results of implementing noise restrictive measures have impacted the community. A case study performed by Siemens in Brussels, Belgium, shows the difference of noise levels over the course of a decade when the pass-by noise levels were reduced to a lower limit. This case study will be discussed later in the presentation. Analysis is often conducted to determine the source of a noise that is causing high readings. This is called exterior noise contribution analysis. An array of receiver microphones are placed on each side of the chassis dynamometer at a distance of 7.5 meters from the vehicle, and a microphone placed at each vehicle component in question. The frequency response function is used with the volume velocity sound source to determine the parts of the vehicle that were contributing to the undesired noise. The FRF is the ratio of the system input to the system output, and is a mathematical way to see how inputs and outputs are related. From the figure shown here, the red indicator microphones are the input, and the blue receiver microphones as the output. The contribution analysis program uses FRF to determine how the vehicle components impact the overall pass-by noise levels. The pass-by noise test by ISO 3623-2016 is to be conducted inside a semi-anechoic chamber to determine the true pass-by noise levels of road vehicles. Testing can also be conducted outdoors by following ISO 3621 specifications. However, indoor testing is preferred to reduce the chance of surrounding noises and extraneous variables. The vehicle's interior and exterior noise is measured during this test by using a chassis dyno and a row of microphones along the vehicle. The chassis dyno allows the test to be conducted without having the car to move physically, and it passes stationary microphones. The indoor setup can be seen here. Data is commonly acquired through data acquisition software called Pulse, which receives inputs from LAN-XI, a data acquisition software, which then determines the pass-by noise levels of the vehicle. Due to the great amount of surrounding noise when conducting the test outdoors, more equipment is needed to maintain accurate results. Photocells are used to determine the position of the moving vehicle. A speedometer is used to assure that the vehicle is moving at a constant speed, and a weather station is required to account for surrounding weather noise. The pass-by noise setup can be seen here.
For testing purposes, the outdoor setup is used to approve vehicles and make sure they're compliant with the regulations. Meanwhile, the indoor setup is primarily used for manufacturers to test their own vehicles and use that information to improve their design before they get tested for approval. This is an effective way to repeat the test multiple times to get consistent and reliable results before moving on to outdoors, where a lot of extraneous variables come into play. When designing and testing new cars, it's important for manufacturers to abide by government laws and regulations that limit pass-by noise levels of automobiles for the safety and well-being of the surrounding communities. In Brussels, Belgium, the limits were decreased because as local population started to increase, so did the overall total pass-by noise levels. This led to disturbances that were overwhelming for the surrounding communities. Also, the pass-by noise limits were reduced because tests were performed while accelerating. Meanwhile, new testing is performed at constant speed with no acceleration. This is quite different because automobiles accelerating produce much louder noise levels due to the increased revolutions per minute. This can arguably be seen as contributing to the overall noise levels that engineers are trying to avoid. However, it makes sense because vehicles don't often accelerate with a wide open throttle. The Government of Canada has its own set of standards when it comes to automotive pass-by noise, described as noise emissions. According to the Noise Emission Standard 1106 by the Government of Canada, the pass-by noise level cannot exceed a certain dBA value for specific classes of automobiles, as shown here in a summarized fashion. Due to the fact that electric vehicles, or EVs, have no exhaust or intake, the largest contributors to pass-by noise is the motor and tires. For this reason, EVs output a much smaller noise level compared to vehicles with internal combustion engines. However, since EVs are so quiet, they can be dangerous because other drivers can't hear the vehicles before. Therefore, they may not be aware that it is near them. The European Union has made it mandatory for EVs and hybrids to have acoustic vehicle alert systems, AVAS, that will make noise when the vehicle is traveling at slow speeds. The AVAS is implemented and made mandatory to increase the safety of the vehicles so other drivers, pedestrians, and the visually impaired are fully aware that the vehicle is nearby. To conclude, this research paper went into detail about automotive pass-by noise techniques and standards, and after a thorough investigation through many resources, we found many case studies that have been conducted to determine the pass-by noise level experienced by local populations and how the results of implementing noise restrictive measures have impacted their communities. We discussed various methods of testing for different types of automotive vehicles, the specific standards for the respective allowable noise emissions, and many other important topics surrounding automotive pass-by noise. Thank you for listening, and we'd be happy to answer any questions you might have. And here are references also.